By late 1944, the tide of war had turned decisively against Germany. American, British, and Canadian forces had broken out of Normandy and were racing across France toward the German border. Behind them, supply officers worked frantically to keep fuel, ammunition, and spare parts flowing to the rapidly advancing armies. Every gallon of gasoline had to be shipped across the Atlantic, offloaded at French ports, and trucked hundreds of miles to the front lines. Fuel economy was not just a peacetime concern, it was a matter of operational success or failure. The American military had standardized on a family of half-track vehicles for its mechanized infantry and artillery support. Chief among these was the M3 half-track, a vehicle that would become as iconic to the American war effort as the Sherman tank or the Jeep. Produced by the tens of thousands, the M3 was powered by a white 160AX engine, a six-cylinder gasoline engine that produced 148 horsepower. It was not particularly powerful by the standards of heavy trucks, but it was reliable, relatively simple to maintain, and most importantly, it could be mass-produced using components from American commercial truck manufacturers. The M3 could carry a driver and 12 soldiers in its armored body, or tow light artillery pieces. Its 60-gallon fuel tank gave it a range of approximately 220 miles on roads before refueling, which works out to roughly 3.7 miles per gallon on paved surfaces. Off-road, through mud or sand, that figure dropped considerably, sometimes to as low as 2 miles per gallon. American soldiers knew their half-tracks were thirsty machines, but they accepted this as the price of mechanized mobility. The German Sd.Kfz, by contrast, was a different beast entirely. Developed in the mid-1930s as part of Germany's program to create a family of standardized military tractors, the Sd.Kfz was designed to tow heavy artillery pieces, particularly the famous 88mm flak gun and the 150cm SFH-18 howitzer. Where the M3 was built for carrying infantry, the Sd.Kfz was built for raw pulling power. It was powered by a Maybach HL62TUK engine, later upgraded to the HL64TR, six-cylinder, water-cooled gasoline engines producing 140 horsepower, remarkably similar in output to the American White engine. But here is where the similarity ended. The Maybach engine displaced 6.2 liters, later 6.4 liters, significantly larger than the American unit, and it consumed fuel at a rate that would shock American maintenance crews. German technical manuals listed the Sd.Kfz-7's fuel consumption at approximately 80 liters per 100 kilometers on flat roads, which works out to roughly 3 miles per gallon on paved surfaces. Off-road, through mud or sand, that figure dropped considerably, sometimes to as low as 2 miles per gallon. American soldiers knew their half-tracks were thirsty machines, but they accepted this as the price of mechanized mobility. These figures were not that American intelligence analysts had paid much attention to during the war. After all, when you're fighting against an enemy, you care about their tanks' armor thickness and their guns' penetrating power, not how many miles per gallon their trucks get. But in the spring of 1945, as American forces overran German positions and captured equipment by the hundreds, some enterprising soldiers and officers began to take a closer look at what they had seized. The story really begins in March of 1945 in the Rhineland, as American forces prepared to cross the Rhine River and drive deep into the heart of Germany. The Ninth Army, under Lieutenant General William Simpson, had been tasked with a massive river-crossing operation. It was during this chaotic period of preparation that elements of the Ninth Army's supply units came across a nearly intact motor pool that had been hastily abandoned. Among the vehicles left behind were several Sd.Kfz-7 tractors, apparently abandoned due to lack of fuel, a common fate for German vehicles in the final months of the war. Unlike many captured vehicles, which were damaged or stripped of useful components, these half-tracks were in remarkably good condition. A young captain in an ordnance company made a decision that would prove illuminating. Rather than simply cataloging these vehicles, he decided to put them to immediate use. His unit desperately needed heavy towing vehicles to move artillery and supplies forward. The immediate impression was positive. The big Maybach engine roared to life with authority. The tracks bit into the muddy ground with impressive traction. When hitched to a heavy artillery piece, the Sd.Kfz-7 pulled it without strain. For the first day or two, everyone was impressed. Here was German engineering at its finest, they thought. Robust construction, powerful engine, excellent traction. But then the fuel consumption figures started coming in, and the picture changed dramatically. Each captured Sd.Kfz-7 had been issued a full tank of American gasoline, 57 gallons, roughly the same as an M3. The American drivers knew that their own M3s could go 200 miles or more on a full tank, even when towing artillery, so they were shocked when after less than 90 miles of mixed road and cross-country travel, the Sd.Kfz-7s were running on fumes and demanding refills. The German half-tracks were consuming fuel at nearly double the rate of the American M3s.
The ordnance captain ordered his men to conduct a systematic test. They selected one Sd.Kfz-7 and one M3, both in good mechanical condition, and carefully filled both vehicles' tanks to maximum capacity. They planned an identical route, 25 miles of paved road, followed by 15 miles of moderate cross-country terrain, and then 25 miles back on pavement, with each vehicle towing a 15-centimeter howitzer. The results were startling. The M3 completed the 65-mile circuit and still had fuel remaining in its tank, having consumed approximately 17 gallons for an effective fuel economy of roughly 3.8 miles per gallon. The Sd.Kfz-7, running the identical course, consumed every drop of its 57-gallon tank and needed an emergency refill to make it back to base. Post-test analysis indicated it had burned approximately 63 gallons for the same 65 miles. That worked out to barely 1 mile per gallon. If you needed to move a battalion's worth of artillery 100 miles with M3 half-tracks, you would burn roughly 2,600 gallons of fuel. Do the same job with Sd.Kfz-7s, and you would burn approximately 6,300 gallons, more than twice as much. Scale that up to division, corps, or army level, and you were talking about tens of thousands of extra gallons of fuel per day. The American officers began to understand something. The German military had designed its vehicles with an assumption that fuel would always be available. They had not designed their vehicles with fuel efficiency as a priority. American military planners, by contrast, had always operated under the assumption that every gallon of fuel was precious. American industry had developed engines that squeezed every possible mile out of every gallon. The Germans had built for power and performance. The Americans had built for efficiency and sustainability. This pattern repeated itself again and again with other captured German vehicles. German trucks consistently consumed more fuel per mile than their American counterparts. The German armored vehicles, the Panther and Tiger tanks, were notorious fuel hogs, managing less than 1 mile per gallon, even on roads. The German military was exquisitely designed for short, violent campaigns where fuel could be captured or stockpiled. It was terribly suited for long wars of attrition where every gallon mattered. By 1943 and 1944, with Germany fighting on multiple fronts and the Allied bombing campaign targeting synthetic fuel plants, the fuel hunger of German vehicles had become a critical vulnerability. American soldiers examining captured Sd.Kfz-7s began to notice other details that reinforced this pattern. The vehicles were built like tanks, heavy and over-engineered. The Maybach engine, while powerful, was a complex piece of machinery that required careful maintenance. When its precision fuel injection systems were not perfectly tuned, fuel consumption increased even more. The American white engine in the M3, by contrast, was simpler, more forgiving of imperfect maintenance, and designed from the outset to be fuel efficient, a legacy of American consumer-driven automotive engineering. The practical implications on the battlefield were stark. An American mechanized infantry company with 12 M3 half-tracks could operate for a full day's combat operations with approximately 200 gallons of fuel. The same company equipped with German Sd.Kfz-7s would need closer to 500 gallons for the same operations. An American frontline division required approximately 50,000 gallons of fuel per day for all its vehicles. A German panzer division, with its less fuel-efficient vehicles, required closer to 75,000 gallons per day. When Germany was winning, this was manageable. When Germany was retreating and Allied bombers were hitting fuel production facilities, it became impossible. American soldiers driving captured Sd.Kfz-7s in the spring of 1945 found themselves stopping for fuel twice as often as they would in their own vehicles. They found themselves watching fuel gauges drop with alarming speed. They found themselves understanding in a visceral way why so many German vehicles had been abandoned on roadsides with empty tanks. The Germans had not abandoned those vehicles because they were mechanically unreliable. They had abandoned them because they had literally run out of gas. In one particularly revealing incident in April 1945, a mixed supply column of American M3s and captured Sd.Kfz-7s was tasked with a round trip to a forward artillery position. The American half-tracks completed the round trip without requiring any refueling. The German half-tracks, running the exact same route, had to be refueled at the midpoint of the journey. Without that emergency refueling, they would have been stranded. This was not an isolated incident. An artillery battalion that briefly used captured Sd.Kfz-7s reported that while the German tractors had better traction in muddy conditions, they required fuel trucks to accompany them on every movement, which negated their tactical advantages by increasing the size and vulnerability of the convoy. It was as if German engineers had not fully appreciated how much fuel their vehicles would actually use under combat conditions. The irony was not lost on American tankers and truck drivers. Here they were, operating in the heart of Germany, with fuel being shipped from Texas and Oklahoma, keeping German-designed vehicles running. The Germans, fighting on their own soil, could not keep their own vehicles fueled. What did that say about the sustainability of the German war machine? By the spring of 1945, German fuel production had collapsed to less than 1 million tons per year, a drop of more than 80% from its peak. Allied bombing of synthetic fuel plants and the loss of the Romanian oil fields had devastated their supplies. But rationing could not overcome the fundamental problem that German vehicles needed too much fuel. German panzer divisions were frequently immobilized, unable to maneuver or retreat, simply waiting for fuel that never came until Allied forces overran them.
The Sd.Kfz-7 and other German vehicles had once epitomized mechanized warfare efficiency, but were now seen by American soldiers as examples of impractical excess. The broader lesson was being learned. German equipment looked impressive, but the German military had not solved the fundamental problem of modern mechanized warfare: how to keep your vehicles supplied with fuel. General Dwight Eisenhower had famously said that amateurs talk strategy while professionals talk logistics. The fuel consumption comparison was a perfect illustration. The Germans had built tactically superior vehicles in many cases, but these tactical advantages meant nothing if the vehicles could not be kept supplied with fuel. The American logistics system, stretching from oil wells in Texas to the front lines in Germany, moved millions of gallons of fuel every day. American units rarely faced fuel shortages in the final year of the war. The German logistics system, by contrast, had broken down completely, and the high consumption rates of their vehicles would have been a burden even in a best-case scenario. American tank crews noted that a captured German Panther tank, while impressively armed and armored, consumed fuel at approximately half a mile per gallon, while a Sherman tank achieved closer to 1 mile per gallon. The Panther needed roughly twice as much fuel to cover the same distance. By April of 1945, captured German vehicles littered the roadsides by the thousands. A significant percentage had simply been abandoned when they ran out of fuel. The German soldiers had left them behind not because the vehicles were broken, but because there was no more gasoline to put in their tanks. The Battle of the Bulge in late 1944 had been Germany's last major offensive in the West.
Its fundamental assumption was that German forces would capture American fuel dumps to sustain their advance. When American defenders held or destroyed key fuel dumps, the German offensive literally ran out of gas. Panther and Tiger tanks were found abandoned with empty fuel tanks just a few miles from their starting positions. Sd.Kfz-7s towing artillery pieces were abandoned when they could not reach the advancing infantry they were supposed to support. Post-war evaluation at Aberdeen Proving Ground in Maryland confirmed what frontline soldiers had learned. German vehicles were marvels of engineering, but horrendously inefficient in terms of fuel consumption. The Maybach HL62 engine in the Sd.Kfz-7 consumed approximately 30% more fuel per horsepower produced than the American White 160AX engine. German engineers had optimized for power density and reliability, not efficiency. Their design choices, such as a low compression ratio, a complex fuel-rich carburetor system, and conservative engine timing, all contributed to significantly higher fuel use. The transmission and final drive ratios were also set to prioritize pulling power over cruising efficiency. In short, the Sd.Kfz-7 represented excellent German engineering applied toward the wrong optimization targets. The economic implications were staggering. American forces in Europe consumed approximately 300 million gallons of gasoline per month by early 1945. If American vehicles had consumed fuel at German rates, this figure would have been closer to 500 million gallons per month. This additional requirement might have delayed Allied operations by months. Germany, with its far more limited fuel resources and inefficient vehicles, was immobilized even when defending its own territory. Some historians argue that Germany's fuel shortage was the single most important material constraint that determined the war's outcome in the West. The Sd.Kfz-7 became a symbol of this failure. It could tow heavier loads and traverse worse terrain than the M3, but it needed twice the fuel to do it. In a war where fuel logistics determined success, that extra fuel consumption was not a minor detail, it was a fatal flaw. The Germans had learned this lesson too late. The Americans, perhaps through pragmatism, had built their military machine with efficiency in mind from the start. When American soldiers climbed out of those captured Sd.Kfz-7s in the spring of 1945 and calculated how much fuel the big German tractors had consumed, they understood that the Third Reich had not just failed strategically or tactically, it had failed logistically. Power without sustainability is ultimately weakness. Performance without efficiency is ultimately failure. The American M3 embodied the belief that adequate quality combined with superior quantity and sustainability would prevail. History proved the Americans right.